Hi everyone, welcome back to my channel, and again this video is going to be part of our design pattern series, and in this video we are going to study one more structural design pattern, that is bridge design pattern. So bridge design pattern separates abstraction from the implementation, so they both can change independently. I know it's very hard to understand bridge design pattern with just simple definition. So now let's move to our blackboard and understand it with the help of one example. So suppose we have this food interface, and food interface can be implemented by multiple classes, and I've just taken an example that it is going to be implemented by this pizza class, burger class, and this pasta class. So there is one food interface and it is going to be implemented by this pizza, burger, and the pasta class. Now in our restaurant, think of this like that: if we have this food, pizza and burger, and in our restaurant we have veg options and the non-veg options. So total number of classes, if you think, there will be there can be an option of pizza veg, pizza non-veg, burger veg, burger non-veg, pasta veg, and the pasta non-veg. So total we have 6 combinations here. Let's move to the code and let's understand it. So first of all, I want you to read this comment section so that you can understand the intensity of the problem. Suppose I have the food, burger, pizza and pasta. And now I increase the type. We have the types veg, non-veg and the vegan. And suppose I have to make the classes. In that case, we have 3 food classes and we are going to have the 3 types. If I make the total number of classes, then it is going to be 3 cross 3 equals to 9 classes we have to make. And suppose if I add one more food, let's say if I add, let's say one more food, what should I add? Let's say if I add nachos, and we have 3 type of nachos as well, veg, non-veg and vegan, then the combination is going to be 3 cross 4 equals, it means that we have to make 12 classes. What I mean by that, we have to make these 12 classes. Let's go to the code and understand it. So suppose if I want to make a pizza, so there is not a normal pizza, we have to make a veg pizza. In that case, what we are going to do, this is the pizza, this is our non-veg pizza preparation, we have this non-veg pizza preparation, we have this veg pizza preparation, we have this veg burger preparations and non-veg burger preparation. So what we are doing, it means that whenever we have one classes, let's say we have one section that is of food and we have another section that is of types, okay, and whenever they are making cross join, let's say what I mean by the cross join, that everything is multiplied with the help of these types. The burger is going to multiply with veg, burger is going to multiply with non-veg, burger is going to multiply with the vegan. So same pizza is going to multiply with veg, non-veg and the vegan. Whenever we have this type of cross combination, we have to use this bridge pattern, because and whenever we are going to have multiple type of foods and whenever you're going to have multiple types of types, then we have to make so many classes. So, and this is something that we don't want to do. So we can say that bridge separate abstraction from the implementation. So food is going to act as the abstraction here, abstraction from the user, and type is going to be known as the implementation, and bridge pattern is going to separate them and it is going to reduce the classes exponentially. Let's see it. I'll just take again back to the blackboard and you will see the difference in the architecture and you will see how we are going to reduce the number of classes as well. So let's go to the notepad. When I'll go to this notepad, just see this thing. Now we have this food interface. That is something that I'm going to show in our good code as well. We have this food interface and that is implemented by this burger, pizza and pasta. And in the types, we are going to have veg, non-veg and vegan. And we are going to create one bridge between them. There is going to be only one bridge. So it means if we count the number of classes here, so we have 1 class, 2 class, 3 class. Let's say consider this interface also, then we have 4. We have this type interface 5, 6, 7 and 8. So total number of classes that we are going to make it here is 8. But previously, if we have these 3 classes, so 3 and we are with 3 classes here, so we are going to create 3 cross 3 equals to 9. And now we have reduced one. But think of it, let's say if we have let's say we have 10 number of food and 20 types. In that case, we are going to make 200 classes in our code, and but with the help of the bridge, how much classes we are going to make? 10 plus 20 plus let's say two interfaces, two, and let's say one bridge also. So it is going to be around 32 classes. 32 classes that we are going to make, and other than that we have to make 200 classes, and that is not possible. So that is why bridge pattern comes to the role. This food is known as the abstraction from the client, and this type is going to act as the implementation of this abstraction, and bridge is going to separate them in a good way so that we are going to reduce the number of classes. And the second problem that bridge pattern is going to solve means that we can add extra number of implementations, we can add extra number of abstraction. It means that we can add some other food type, it means that we can add some other food item, it means that we can add other types as well. It will not break the solved principle. Now let's see the code of this bridge pattern. So now we are going to use the same thing. We have already discussed this bad code that we have to make so many non-veg burger class, non-veg pizza class, veg burger class, and veg pizza class. And this is also we have studied about this cross combination. So now let's move to the good code. For the good code, I have taken the food equals to burger and pizza, and the types that are our implementation that are going to be veg and the non-veg. Here we are not going to do a cross combination. Here we are going to make a bridge. So let's see how we are going to make it. So first of all, we'll go to this type interface. Okay, this is the food type, that is apply type, that is, and the type is going to be implemented by the veg and non-veg. So let's go to this non-veg class that is saying I am non-veg class that is implementing the food type. It is saying non-veg, and the veg type that is implementing the food type that is saying that I'm veg. I think this is pretty clear. We have just completed three classes: food type, non-veg class, and the veg class. Secondly, now this important part now comes to an important part, this food class. So this food type says that I'm going to take food type as a parameter. Food types are going to be of two types. It can be veg or non-veg, because these are the two classes that have implemented it, and let's say in the future we can add vegan as well. So these are the two types that we can add in it. I'll just mark it as a comment, and we are passing it into this food class. Type this dot type equals to type, and now we have this abstract void function prepare. It means that whoever is going to implement this food class have the food type also. So let's say if the burger is going to implement it, if burger class implemented it is having the food type, and we are just passing the super type, and in the prepare function we are preparing. Similarly, if we go to this pizza class here also, it is also taking this food type. Now when we'll go to this restaurant, you will see what we are going to do. In the food, we are saying it is a veg pizza. In the new pizza, we are passing this new veg. How we are passing this veg class here? Because veg is going to be implemented by the food type, and the pizza is implemented by this food class, and this constructor is asking for this food type parameter. So that's why this code is like that, new pizza, and in the bracket we are passing new veg. And this is how we are going to create a bridge. So I'll just again repeat it one more time. We are creating the bridge with the help of this abstract class and with the help of this constructor. Okay, so this is how we are going to create a bridge between the food and type. And then think of it, let's say if we add a new vegan class in it. Okay, so what we have to do, we have to just make one vegan class, and in that vegan class what we have to do, we have to just implement this food type, and we can just make the new combination. We can just say then after that new pizza, and in the bracket we can just pass new vegan. So our new vegan pizza is ready. So we don't have to make separate classes like pizza vegan, burger vegan, nachos vegan. We don't have to do all this. With the help of this method, with the help of this bridge design pattern, we solve all this complexity. Think of this like that. We converted multiplications into addition. Like think of the like 6 cross 6 is going to give you 36, but 6 plus 6 is going to give you 12. That is a difference that our bridge design pattern going to create. So I'll push all this code into the GitHub, and I will put it into the description so that you can understand it really well. So thank you for watching me, and let's meet in our next video, and bye bye.